the idea that and also that they're connected, right? They're connected in some sort of almost like a neural network. And there's what is that thing in the Pacific Northwest, the one fungus group that's essentially the largest living organism on the face of the earth?
Yeah, the largest organism in the world so far discovered is a mycelial mat, 2,200 acres in size, and that's equivalent to about 665 football fields.
And that's one animal.
It's one mycelial mat. One mycelial mat is a honey mushroom that kills trees. It's an edible mushroom. But think of this. I mean, so for those listeners out there, if any soil biologists know this well, if you go out and get some nice rich soil, a gram of it, and you analyze it, there typically is 1 million, 5 million microbes per gram in that soil. Now the mycelium is growing out. We have 5 or 6 skin layers that protect us from an infection. The mycelium only has one cell wall. On the other side of that cell wall are hundreds of millions of microbes per gram that are trying to consume it, many of which the mycelium is able to upregulate in constant biomolecular communication with this ecosystem, be able to prevent predators from consuming it, thus allowing it to achieve the largest mass of any organism in the world. This is amazing to me because it means that it is constantly in communication with the ecosystem, being challenged, accepting alliances. So guilds of microbiomes are being created, selected by the mycelium. And these guilds and communities then cooperate in order to prevent pathogens, parasites, even competing guilds from coming into that landscape. So the dominance of these fungi are to ensure the ecosystems that give rise to their progeny. The rule of natural selection in life is reproduction. So everything steers towards reproduction. So from an evolutionary biology point of view, what will that organism do to help survive so it can reproduce? And reproduction through creating guilds of communities of the microbiome using the mycelial network as the structural foundation of the food web seems to be the name of the game here.
So this honey mushroom, is that what it's called?
Yeah.
And that lives in the Pacific Northwest, how is it killing these trees?
It's a root parasite. So it comes in and it kills the trees. And I spend a lot of time in the old growth forest and a lot of hiking. I've always been wondering about meadows in the subalpine regions. There's all these subalpine forests, and then you come out and there's these giant meadows. Well, I suspect that this honey mushroom is a meadow maker. It climaxes these trees, it kills them, they then die, and then they grow saprophytically, but then it clears the canopy so the grasses landscape.
Saprophytically? What is that?
Saprophytic means it's growing on dead material. So first is a parasite.
You mean the mushrooms?
The mushrooms. First is a parasite, kills the tree, then it's a saprophyte, or saprobe is another word for it. It's a decomposer. It breaks down that material. But as it decomposes the wood, 30% of wood becomes water. So the mycelium generates water. Whoa. And so water lenses are being created. Now you have more sunlight, grasses then flourish. And so I've suspected that these mushrooms are actually meadow makers, allowing then the elk and the deer and marmots and whatnot to exist in those grassland environments as a way of rebuilding the nitrogen source in the soil. So I think these are over great, huge timescales. We have to get away from the concept of our lifespan, or even 100, 200 years. We need to think in millennial terms, over many, many millennia.
This is unbelievably fascinating. The idea that they're sort of the architects of their ecosystem.
They're the architects of our existence. This is something that there's some really fantastic research that's come out in the past 2 years. I'm a science ambassador for the AAAS, the American Association of Advancement of Science. So I am a little bit out there, but I'm really happy that I have so much scientific support these days, because a lot of things I've been talking about for 20 years are now well-rooted and been proven. One of the things that has been so fascinating to me, and I'm still wrapping my mind around this, but the universe was created about 13.8 billion years ago from the Big Bang. The Earth coalesced out of stardust about 4.5 billion. The earliest records of life we have is about 3.8 billion years ago, single-celled organisms. But just recently in lava beds in South Africa, they found mycelium infused through the lava 2.4 billion years ago. Now, we split from fungi 650 million years ago. And then in Brazil this past year, they found a fully intact apparently a fossilized mushroom published in Nature, which is a very, very reputable scientific journal. And that one is 1.4 billion years old. So the oldest multicellular organism in the fossil record today is this fungus in lava in South Africa 2.4 billion years ago. A fully formed mushroom who had its form was growing 1.4 billion years ago. We separated from fungi 650 million years ago. Mushrooms have had their form longer than we've had our form by more than 1 billion years.
Here, Jamie just pulled it up on the screen here so we could take a look at it.
The one from Brazil.
So this is the Paul, is this the image that you're familiar with?
Yeah, this is the one that has just been published in the past. They have a great name that's a tongue twister to pronounce. It's Gondwana agaricides magnificus.
Why do they do that? Do they do that to make people like me feel stupid? They don't have to.
No,
I
they
feel
do that
stupid
because
already.
graduate students want to publish papers and so they can invent names. So.
And so it looks better if you have a long Latin-sounding name.
So, but think of that. Mushrooms had their form before we had ours.
Yeah.
These are elders. These are ancient organisms. These are the overlord underlords of our ecosystem. And I suspect, and as these neural networks, they have more neural connections in the mycelial mass. They're over 1,000 acres than we have in our brain. They are actually accumulating not only genetic intelligence, but I think that as time goes on, I hope that we will be able to interface with them, because I think that there is many benefits of us communicating with mycelium that can give us rapid responses to catastrophia. That's how they've evolved. And we're now the biggest walking catastrophe that I know, walking across the planet. And we need to engage these fungal allies for the benefits that we need to put into play in order to prevent the loss of biodiversity.
It seems like a communication gap would be very hard to bridge. The communication gap, I mean, if we really did find a way to communicate in some form with mushrooms, like the concept of language, like you were talking about, just the idea of nature and intelligence and these words that we have these sort of concrete definitions in our head that don't really apply to some things that are very, very confusing to us, like the idea of fungal intelligence, the idea that you could somehow or another understand the language that these things, we don't even understand dolphin language, right?
Well, one classic example, Japanese are so clever at this. There's a slime mold, called Physarum polycephalum, and they had and this slime mold is very, very good at navigating through mazes and challenges. I mean, first to food wins. The conservation of energy, is rewarded. So you
so
don't
how do
want
they
to
set this up? They put a little bit of it.
They did several experiments. The most fun one is they designed a nutrient, basically a nutrient-like maze, replicating Tokyo in the Japanese subway system. And so they started with Tokyo, and they put oats, which is a nutritional source. They inoculated what is on this basically an agar map with all the major cities, the nodes around Tokyo, and they then each of those nodes had a piece of oat on them, which was a source of nutrition. The main oat was where Tokyo was. They inoculated it, and then they let the slime mold then grow. And first it grew out randomly, exploratorily, just like you would do if you're a hunter or something. You're hunting on the landscape looking for things. And then after about 28 hours, it reorganized itself in the most efficient way possible and reorganized the Japanese subway system in a more efficient manner than it's designed today. Thus, they said, not me, not Paul Stamits, this is a demonstration of cellular intelligence.
Whoa.
So this is the tip of the proverbial mycelial iceberg. This has broad implications. And I just want people to suspend their disbelief. And this goes into actually the evolution of human consciousness. And Terence McKenna was a good friend of mine. I love Terence. I especially loved him the last 5 years of his life because he made fun of himself so much. Terence, people took Terence way too seriously in many levels, but as his brother Dennis which I think has been on your show
a couple times.
Yeah, Dennis is a great,
Love that guy.
Great ally, great scientist. But Dennis said even if 10% of what Terrence said was true, it's friggin' amazing. And Terrence and Dennis both came up with a stoned ape theory. Now it's not a theory; it's a hypothesis. A hypothesis is speculative, but cannot necessarily be as not yet proven. A theory is a hypothesis that has been tested and proven with facts. So I disagree with them in saying it's not a theory; it's a hypothesis. But the hypothesis of the stoned ape, which I think you've alluded to before, is that with climate change and as the savannas increase and our primate ancestors came out of the forest canopies, they're tracking across the savanna. And if you're a hunter, what do you look? You look for footsteps and you look for scat. And the most significant fleshy mushroom going out of poop in Africa, hippopotamus, elephant, deer, antelope, etc., is Psilocybe cubensis. It's a very large mushroom. You're hungry. You're with your clan. You consume it, and then 20 minutes later, you are catapulted in this extraordinary experience. Psilocybin substitutes as serotonin, becomes a better neurotransmitter, activates neurogenesis. It causes new neurons to form, new pathways of knowledge. So that's a stoned ape hypothesis, and it speaks to a mystery that the human brain, basically the brain cavity doubled in size in about 2 million years. Some people say it's less than 200,000. Homo sapiens
less than 200,000 years?
Yeah. Homo sapiens arrived 200,000 to 300,000 years ago.
That's a big gap, right?
It's a big gap. Well, the science is like that. So you want to be scientifically accurate here, I need to show the extreme margins of what's been estimated. So if we accept 2 million years that and it's been shown in the fossil record, this is true. The oldest Homo sapien fossils are 300,000 years old now. But we have a suddenly doubling of the human brain. And with that, our language centers increased, our ability to prognosticate, to plan. And there's no explanation for this currently. And even though we may not be able to prove it, I ask people to suspend their disbelief for a second. Now think of this. Our primate ancestors are going across the savanna. They ingest these mushrooms as a clan. Massive input for anyone who's eaten these mushrooms. Huge amounts of data is coming in. Fractal patterns.